640 crickets were seen outside the school. Okay. If other 160 crickets, okay, well, I don't know what that means exactly. Other 160. Okay, I guess it's another group. Were not seen. What fraction of crickets were not seen? Okay. Okay. What is what is the interpretation?
I got halfway through this one.
Okay.
But yeah, I did it wrong.
Okay, but what do you think you should do? Yeah, the 160 to me, the way it's worded is not the best writing here. It's another group of crickets. Is that okay? That's how I see it. And then the first group of cricket is 640. That's fine. But the question is, what fraction of the crickets were not seen? I think the way they're trying to describe it is that let me see, if the other 160 crickets were not seen, the other crickets were not seen. You might be thinking, isn't that the answer? No. What fraction? Okay, when they say what fractions, it seems like you have to combine the two groups. The other 160 crickets were not seen. What fraction of the crickets were not seen? Okay, yeah, I see. All right, so I'll let you think it first. I got it. Yeah, yeah, it's kind of tricky. What do you think? I'll let you think.
So like what fraction out of the ones weren't seen out of the ones that were seen?
Actually, out of the whole thing. Out of the whole thing. What do you think? Out of the whole thing. The whole thing means that there's
160 over 640, and then you reduce it.
But what about the 160? Oh yeah. Oh, I see. You thinking 160 out of 640? Is that what you're thinking?
Yeah.
I know. It's kind of messy here. The way it's worded. If the other 160 crickets were not seen, okay, that means 160. It's independent from the 640. So the way I was seeing it as a group, I was right. I'm thinking it. I'm pretty sure. That means you have to combine those two groups, and then that will be the total. Then you put the 160 over it, on top of it, to get your fraction. Get it? So pretty sure. Okay. So here we go. So here's the actual math for number 3. I'll write it somewhere. I'll go ahead and put it here. Okay. So for number 3, I would do 640 plus 160 equals, what is that? 700, 800. Then I would take the 160, which is exactly what they're looking for, out of 80. That would be it. See? But you gotta reduce that. So what fraction of the crickets were not seen? There it is, the 160. But reduce that. Divide the top and the bottom by 10, or scratch out the end zeros. Like that. You take them out like that. Then look at it again. It's 16 over 80, which is reducible further. Let me see if I can erase this. I'm pretty sure I can if I go on the bottom layer. Okay, cool. Oh, and I'm able to keep. That's pretty cool. All right. So you're left with 16 over 80. Biggest number that can divide into both. What do you think? If not, we could use any even number, I guess. No, not
8.
even. 8. Yes, 8 seems to be the biggest number. But it's actually not. It's 16, dude. But it's okay. Let's do 8. 8 can go into 16 2 times, and 80 10 times. But then continue. Divided by 2, you get your 1/5. So that should be the answer. I'll double check it, but I'm sure it's right. It's a little tricky the way it's worded. It's like confusing. Are they talking about the 160 being part of this, or is it separate? That's what a lot of students would think, right? Like, is it 160 is in there? No, it's actually, it's the way I see it is because of the word the other. The other is not like in there. Get it? So this is what I see. It's possible that it's 160 over 640, but I don't think so because that's too easy. Yeah, the way it would be too easy. All right, anyway, number 4. Oh, no unit. Okay, it's just a fraction. Oh yeah, if you wonder what unit is that? No, it's just 1/5 as a fraction. Is that okay?
Mm.
All right, 4. So I make the big screen bigger here. All right, the speaker used 62 of the author's sentences verbatim. Okay, what fraction of the author's 80 sentences were used verbatim? Okay, another confusing one, but I think I got it. What do you think?
So you do f times 80 equals 62, and then you divide both sides by 80, and then but you don't divide the last side. You do 62 over 80, and then you reduce it.
Wait. I think that's a little too fancy. Let me think. The speaker used 60 of the author's sentences verbatim. Okay, that's used verbatim. What fraction of the author's 80 sentences were used verbatim? Okay, this one is the simpler version of the number 3. I don't think you need to set up the equation. You want to think about it again? Yeah, it's just confusing, man, the way it's phrased.
Our
It's
teacher said we have to set up the equation.
for this one.
Yeah,
Okay, tell
like
me.
for
All right, tell me what did you say? Go ahead. I'll write it and see if it's going to be okay.
I did f times 80
Wait,
equals
F?
62.
Did you say F? F time
Yeah,
80?
or like x, or just a variable.
Okay. X. Wait. Why can't I write that? One second. Okay. I see. It's under the layer. So fancy stuff here. Okay. X times or F. Did you say F? Why did you choose
Yeah.
F? Okay.
Uh,
X
x times 80 equals 62,
62.
and
Yeah.
then you
That
do
works.
yeah, you
That
put it
works.
over 80. Yeah.
Okay. That means number 3. What would you do as an equation then? I
F
recommend you
times
don't. I'm sorry.
800. Yeah,
F
f
times
times 800 equals 160, and you put both sides over 800, and then you reduce.
160. Yeah, you can do that too. Okay, yeah, set that up like that, and then you could go ahead and continue like with that. Is that okay? As you con- continue on step. Yeah, that works. Good. I'm okay with that. All right. So this is correct. So divide both sides by 80. So x equals 62 over 80. So it's as simple as 62 over 80. This one compared to number 3. All right. So it's the biggest number that can divide into 62 and 80? I'm not sure, just half it, right? Even I'm like, what is it? Maybe 4? Yeah, let's just half it. Is that okay? Let's half it. It's going to be 31 over 40. And that's it because 31, it's a prime number. So you're done. Is that okay? So 31 over 40 would be the answer for number 4. Okay, what about 5? There were 2 and 1/3 times as many intrepid students as expected. If 30 were expected to be intrepid, what was the total of the intrepid students? Okay, this one literally is an equation. So I see why your teacher want the things to be set up as an equation. Okay, tell me, how would you do it for 5?
Um,
2/3 times as many
two
intrepid. You
two
can
thirds times
variable x.
2/3 times x equals 30.
Okay, let me see. Looks right to me. There were, we'll deal with improper fraction, the conversion. Like x, this is variable x. I know it looks confusing. It looks like it. See, now you understand, what I was saying about the variable, So I'll curse, kind of like make it more italic. Equals 30. Okay, let me think. Yeah, it looks right to me. So let's convert 7/3 times x equals 30.
And you multiply by the reciprocal.
It doesn't look exactly the way I see it. Okay, let me read it again. I don't think this is right. The equation seemingly is right. Let me think here. 2/3 times as many intrepid students were expected. If 30 were expected to be intrepid, what is the total? Okay, no, this is not correct. You want to think about it again? It's more straightforward than that. So you're gonna, okay, I'll let you think about it first. Number 5. Yeah, it's more straightforward than that. I'll let you read it, okay? And then I'll dissect it. I'll break it down. But go for it one more time. 2/3 times as many intrepid students were expected. You don't have to worry about the word as expected, the phrase expected. 2/3 times as many intrepid students times intrepid students. If 30 were as expected, okay, I guess you get to use the as expected. 30 were intrepid students. What will be the total intrepid students? What do you think?
2 1/3 times 30
Yep.
equals x?
Yes, equals x. So the teacher still want an equation out of it. Therefore, you equals x. Yep, that's it. So 2 and 1/3 times, or I'll parenthesize it, equals x. Yeah, that's more correct. I'm pretty sure. 7/3 times 30 equals x. 3 can go into 30. Is that okay? Let's do cross canceling. 10 times itself one time. Therefore, x is going to be equal to 70. So that's more like it. Yeah. Intrepid students. All right. Okay, so could you tell me the answer for A mentally? I know I keep asking you this because this is something you'll encounter a lot. So you want to be able to do it later on fast.
0.00031.
Let me see. You said 3 zeros, 3 1. That looks good to me. Yep. Is that okay? Yeah. Right. 3 1. Sorry. Yeah. Yeah, it looks good to me. Okay, I know you can do this one. 0.92 times that. Is that okay? Times 0.031. Okay, let me see it complete. How's your? I know you've been off for 2 weeks. Okay, but I still think you're okay, right? With the table. Yeah. Okay, let me see. 8. Jody ran a mile in 8 minutes. Okay, a mile in 8 minutes. So 1 mi over 8 minutes, based on the exact interpretation. mi on top, min on the bottom. Right. 2. Okay, I think you're okay with this one, but this will be like the speed version of it, miles per minute, like miles/minute. But you don't have to divide to get your decimal. I would just leave it like that and then deal with it. Then you flip flop this version, right? And you get 8 minutes over 1 mile, mi. Then you're gonna choose. So that's your A. What is her speed? Oh, you still okay. What do you do with B? Oh, A is done. These two will be your A. What is your B? What do you think B is? Don't worry if you're not sure, because this is actually not just real life, but it's later math, like algebra math that you're going to have to be able to identify. Or you'll see. I'll write. But what do you think? I'll let you think about it first. Then I'll show it to you, and it'll make sense. Yeah, B and C it's in the algebra territory now. Okay, here it is. It's slowly being introduced, but it's okay. What do you think B is? It's actually one of these. I'm not even kidding. What do you think? What do you think? What is B? Is B this? or this fraction. Okay, okay. Like when you drive, on the freeway or wherever, right? Normally on the freeway, you can see like 60, 80, 80 miles. I don't think so. 60 miles per hour, right? You see that. That's the speed, right? So the speed, it has to do with the distance over time. Distance over time. You learn that. It's actually in a formula, right? Rate or the speed equals distance times time. But this, wait, sorry. Rate equals distance times time. No. Distance distance is equals to rate times time. But don't even worry about this because they were trying to teach you real life first before you actually utilize this particular formula. But if you were actually to solve for the rate, which is the speed, by the way, it's going to be d over t. Divide both side by t. Think about it, okay? I know it's like you've been doing numbers, but if you divide both side by t, the t cancel out and you're left with d over t equals r. I think you understand that, right? But don't worry too much about what I'm showing it to you here because it's easier than that. Because if you apply it real life, then you see it immediately. So this is, if you wonder, here it is, okay? This is r. This r is rate or speed. So it's distance over time. D is for distance, T for time. That means time could be any unit, but it has to be time in like hours, days, minutes, seconds. So anyway, back to the miles per hour speed that you saw on the side of the freeway, right? It's miles per hour. It doesn't have to be miles per hour. It could be miles per minute. It could be feet per second. It could be whatever. You get it? So distance. That means this is the one. Tell me you understand, right?
Yeah.
But they don't want you to write it as a 1/8. They want the actual number. So it's going to be a decimal number. And then you can do miles/minute. Get it? Like, you know that, right? Like, the numerator unit will be like the first, and then per or slash will be the division symbol here. And then the minute will be written after. So therefore, you got to do your long division. 8 divided, I hope you're okay. The divisor will be the denominator will be your divisor, your numerator will be your dividend. And then you can write the mi/minute. But let's do the math here. mi/minute. I know it's like, it's but that's what they want. Yeah, this is the only one that they could have written differently, miles, and then make sure that's in hours or something. So it looks like real life that you see, but they chose the minute, so we'll deal with it. Okay, so we're going to do your long division here. All right. I may have to erase that. Okay, put a decimal here, straight up. 8 can go and add a 0. 10 one time. 8, 2. So I got to erase this and carry it over. So the answer would be miles per minute. Or you can write the word per, okay? Per. Right, continue here. 0, straight down. 2, 16. 4, add 0, straight down. 5, 40. Okay, good. It terminates. It stops here. Now, some student may be rounding the answer to 1/3. I recommend you keep all of it. So the final answer will be, your teacher will accept it, has to accept it. No rounding necessary because it terminates like pretty soon, like 3 decimal places. So the answer here it is for B, okay? 1.25. Sorry, make it neat here. Miles per minute. And, it makes no sense. That's why I was saying they should have actually made the problem as miles per hour. Not the 8. Change that number into something small, whatever. It's fine. Or you can use car or bicycle, motorcycle instead of a person running, Okay, so that's B. Does that make sense? I hope you're okay. Yeah. Yeah, it has to do with distance over time. So that's what this is, over division, over time. So that's going to be the answer for B. Okay, at this rate, so here it is. You're going to use this rate. This is your speed. R rate, speed. So here we go. There it is. At this speed or at this rate, how far would she run in half an hour? What do you do? What do you think? You could technically go back to this if you want. You don't have to use the 1.5 if you don't want to, right? You can do both. It'll give you the same answer. But I would use it because it seems like they made this in this order, and they seem to want you to apply it. You know, use your B on C, right? So, right, how would you do it? It's not as because it's it's half an hour. What do you think? What you should do? Let me write it over here. Okay. So here's the setup. Instead of 1/8, like 1 miles over 8, I would do it 1.25 mile over 1 minute. Does that make sense? I think you're good. Okay, now like this. I'm rewriting it, and then I'm gonna times something to get my answer for C. I'm doing C right now.
So it's 0.125 miles over 1 minute times 30 minutes.
Yes. Yeah. Your what do you call it? Unit multiplier, right? Or dimensional analysis, which you'll be hearing more later on in chemistry and beyond. Yes, you got it, dude. That's it. 30 minutes, whatever this is. Cross out. You put over 1, you want to cross out the minute unit, and then your answer will be in miles. So I'll use the calculator here. Okay, that looks good to me, dude. Yeah, you got this, man. Yeah, this one is quite a bit of a challenge here, but no, not really. As long as you get your speed correct, so times 30, is that okay? Okay, so it's 3.75. What is that unit? 3.75. So I'll write 3.75. Ignore what's below it, okay? 3.75 miles. Yeah, don't have to do anything with the decimal here because that's not minutes or not MIN, okay? Miles, MI, not MIN. That's it. Basically, three and 3/4. You know, almost like 4 miles. Is it okay? Yeah, that's it. I'm pretty sure. Pretty sure. Okay, let me see. I think you're good with 9, 10, 11, 12. Yeah.
Mm-hmm.
All right. Okay. Let me see. I want to look at anything fancy that's going to be introduced. It kind of already did right around here, number 8, because we're already looking at this particular formula, dude. That's like for algebra, which you actually been applying. I think you've seen it, but maybe not in the form of D equals R times T. Okay, let me see, 14. What is the volume? Okay, this one, yeah. I think you're good, but let's talk about it. What is the volume of the right solid in this particular one? And the top looks like that, right? Or the bottom. And the height is 2 meters here. So I guess this is like the particular fancy construction of of an art, some kind of monument. I don't know, maybe a sport complex. You know, they squeeze around what do you call it? Like curved. I mean, no, a slanted road, and the other ones were like this and like that. I'm making this up, dude. I don't know. Is that okay? But okay, what do you think you should do again?
So you have to find the area of the triangle and the rectangle.
Yes,
So you do, since the side is 15 and the smaller side is 5, you subtract 15 by 5. So the side of the triangle becomes 10 and the side of the rectangle becomes 5. So for the triangle, you do 10 times, and then since it's 16 here and 15, you have to add 16 and 15, which is 31. So it's 15 times 31 divided by 2, and then for the rectangle it'll be 16 times 5. Then you take those areas and add them, and then you multiply it by 2 meters, and then the answer will be meters cubed.
dude, that came off from your head. That I follow every single word. I think it's exactly right. Everything you said is exactly right. It was a little too fast for me, but it's right. I picked everything up. By the way, yeah, you got it. Like the 1/2 times base times height. Make sure your numbers are perfectly correct. And I think you got it. Like 31 here for the base and the height, and half it, right, for the triangle up here, right? And then you got your rectangle. You said everything. You said it like right there. 5 times 16. Add them up. You know, add this up, right? 5 times 16. So I don't have to write it. And then when you get the answer, and you said times it by 2 for the height, right? That's it. Is that okay? Yeah, dude, you got this.
Yeah.
Yeah, let me double check. 1/2 times base, which is going to be 3116 times 15. That's what you said. And the height is just 15, just that portion. Yeah, and then add,
Yeah.
right, the height. Is that okay? I'll use that as my height for the triangle. Is that okay?
But the height's 10 because you subtract 5.
Yeah, let me see. Let me double
Because the
check.
side of the rectangle is
You,
5
you,
and it
you
cuts off.
okay? Let's see. Let's focus. Let's double check. So let's focus on this triangle. So you want to go again? Tell me.
So it would be 31 times 10.
31 times 10 divided by 2. Is that what you want?
Divided by 2.
Right? One half times, like
Yeah.
the base times height divided by 2. I
Yeah.
actually, no. I was hearing you about subtracting 5 from it. But look, it says right here, let me think, unless I'm wrong, it says that from here to here is 15 no matter what. See?
Oh, I
I,
thought it said from top to all the way to the bottom.
yeah,
Yeah,
okay.
so it's
Yeah, I think that's
so
what you,
it's
yeah. Is that okay? Yeah,
yeah.
that's, so yeah, we're gonna have to take 15 as is. But I get it. That's why you wanted to subtract 5 from it. Okay, good job. Actually pretend that is a more challenging one. Let's say if they say this is 15 and stretch it all the way down. Yep, then you do that.
Yeah, then
They should have done that, by the way. I'm sorry. They should have done that. It would be more what you are not just you, for your class now capable of doing. Okay, but I think you got this now. Okay, so make sure it's 15. Yeah, is that okay? Yeah, so 15 times 31 divided by 2, and then add 5 times 16, right?
yeah.
And that's it. And then whatever that is, and then times that by 2 for the height. Is that okay? Because the volume is the base times the height for any generic solid. The base is this whole thing together. Okay, so let me write it. Let me write the whole thing now. You can copy this down. I recommend you do it. Watch, copy this formula because your teacher wants you to apply it. The base is exactly what you were saying earlier. So here we go. I'll show you how to group it. Okay. So 15. I'll do 31 like you say the way you want it first. 31 times 15 divided by 2 plus 5.16, and then you group this. Order operation, that's your base, by the way. The whole thing is your base, and then here's your height times your height, which is 2. There it is. If you write all this, your teacher has to accept it. Now, careful, this is not 5. See, that's, yeah. You can do X here if you want, okay? It's not 5.16. Let's do X there. Like, make sure it's not variable X. Make sure it's not italic. Okay, that's it. Yeah, I recommend you kind of write it this way because later on, I keep saying that all the time, right? It's going to be very long strings of operation that you have to deal with. That's why you were doing that stuff that you were practicing. Let me see, watch this page here. For that reason, this thing here, you know what I mean? Like with the parenthesis, that's exactly why it's actually applicable to things like what we just did here in one shot, one row. See, that makes sense now. If you ever wonder why do you keep practicing like these long strings of order operations right here, with the grouping, the parenthesis, all that, that's exactly what this is for. For future physics formula that's long, that's a bunch of, multi variable, like I'm talking about moving things or inputs. Yeah, no kidding. Multi-variable, XYZ, you can think it. But yeah, if you wonder, okay, anyway, I think you got that, but let me see. What about 15? What is the circumference and area of the wrestling mat with the radius of 14 feet? Okay, so you can see that this is going to be a circular mat, right? Right? It has the word radius and it has circumference. Not necessarily the area, but okay. Now, what is the circumference again? Do you
Um
remember? I think you're looking up for the formula, right? So
yeah.
I'll write it. But before I write the formula, how would you describe circumference again?
Like the distance all the way around the
Yeah,
circle.
they don't call it like length because it's like you have to cut it. If you can put a string, you have to cut it and then stretch it out. Then it becomes like a length. But yeah,
Yeah.
so they describe circumference like that. Yeah, it's kind of weird, but
Yeah.
yeah, it's a term that in math. Okay, there's two of
So
them.
Yeah, if the radius is 14, then you have to do the diameter. So 14 times 2, which is 28. And then you do 3.14 times 28.
Okay, I see. So you're using the formula that goes like this: pi times diameter, or 3.14.
Yeah.
So you're using that one, but you realize that you can also use this one, right? Have your
Pi,
teacher given you the 2
pi
pi
r
times?
squared. Yeah.
Oh wait, the 2 pi, the pi r square is for the area. Wait, let's do the circumference. There's two versions of it. There's 2 times 3.4 times r. This is my pi. Okay, sorry, that's my pi. What about this particular one? Have you seen that? I've written it for you, but have your teacher introduced it? No.
No.
Interesting. You want to see? But you've
Or
seen me.
I think so.
Yeah, they have to. They
Yeah.
have to. So that means you may want to overlook that one. You could, but you don't want to have to use it if you don't need to. Like make more than what it is. Like you bloating up the problem, like times it by 2. I would use this directly. It's a 2 right there. The 2r is d, right? The 2 times r is already the diameter. I'm sorry. That's why it works. But I recommend you be familiar with both of them. So it's kind of very common. It's very common. And then of course the last one is the area, which is the pi times r squared. Are you still using 3.14?
Yeah.
Okay, so let's do 3.14. All right, let's do the circumference first. But I'll use this one. So circumference, they capitalize it in general. Okay, I recommend you capitalize it. But the lowercase is going to be for the r. So anyway, 2 times 3. I'm not going to put a decimal this time. I recommend you do exactly the way I write it here. Okay, 2 times 3.14. You see why? Because it's a decimal number. You want to do 2.3.14. You don't do that. Parenthesize that or x that. I recommend you don't use x either because you've got too many variable r and all that going on. So do exactly the way I write it here, and then the r is 14. So this is going to be your circumference. I'll punch in the calculator later. So what about the area, right? Wait, let's copy this down, okay? Let's copy it down. I recommend you do exactly the way I have it here. I know your teacher has his certain, way of writing, but it cannot be like way off in what I've written here. This is actually very universal, very standard. I recommend you do everything I've written here. Your teacher will have to accept it, unless like you said earlier, that it's going to have to be written in equation, form. Then okay, that's fine. Then you mod that. Even then, what I mod or written changed. It's perfect. Exactly what your teacher will accept. So yeah, copy this down. Okay, now we're going to do the area, which is 3.14. You don't have to parenthesize the first one. Look at that. This grammar thing here, okay? I didn't parenthesize the 2. I didn't parenthesize the first. I know I'm talking about the numbers, not the C and the A here. Times R, which is going to be 14, and then square. Put the square on the outside here. You can put it inside if you want, but you should put it on the outside because you're substituting the R only with 14. The square is outside. It's up to you, but this is perfectly standard in textbook example. Okay, so I think you can do this. You can use. I think your teacher will let you use the equation, calculator. But the unit. What is the unit for this? For this one and this one?
Well, so for the circumference, it would be feet, and then for the area, it'd be feet squared.
Yes, that's it. So get ready for that. I'll let you do the math here. All right, let's see I hope you're okay. Yeah,
Yeah.
please. Yeah, think about everything I've written here. Your teacher will have to accept. It's pretty much what your teacher should be writing. By the way, I'm pretty sure your teacher, did the same thing on the board or whatever. But let's have a look here. Next page here. Okay, now they're getting fancy here. I've never seen it written as a complex fraction before. A fraction over another fraction. Normally, they would write it as division, right? Like the division symbol. Okay, it's getting there so that you when you actually do this on your own based off a what do you call it, like a word problem, you may have to set up the fraction like this. No kidding. Okay, yeah, you'll get more comfortable writing as a fraction divider fraction. rather than writing like a fraction with the division symbol, like fraction divided by side to side like that. No kidding. When you get on with your algebra, you're not going to be writing it side to side that much anymore. No kidding. You'll be writing it like this for a reason. You get to see why, because you're going to have like x in the denominator, variable x here and all x plus 1 x. No kidding, in the denominator of a fraction on top and a fraction on the bottom, inside a fraction. Okay, but right now, what do you do? Okay, what do you think? Yeah, let me see. What do you do for number 17? What do you do with this here?
So it'll be 1/3 divided by 2/5.
Okay, let's skip
And then
that.
you multiply it by one. It's 1/3 times 5/2.
Okay, good. That's it. And then what? Equals 6 over x. Is that okay?
Yeah.
Okay, I recommend you copy this down. Here's why. They don't want you to rewrite that. I mean, I'm sure your teacher may have been showing you that. Like, this is not wrong at all. It's perfectly
Or no,
right.
it's 1/3 x times 2/5.
No, no,
Or
no.
times
Oh, I see. You're cross
cross
multiplying. Got it. Okay, that's another option. I think this is the option your teacher wants. Got
Yeah.
it. I got it. Okay, good. Okay. Now, but tell me if this is okay too, up here.
Yeah.
Yeah. So yeah, some of your classmates may do one or the other, but I believe your teacher want it this way. Yeah, the way you said it just
Yeah.
now. Yes. Okay. Okay, good. Let's set that up. But don't forget, this can also be done. But yeah, you got it, dude. Yeah, it's exactly right. So here it is. 2/5 x. You could do a dot here. You don't have to parenthesize it. There's no decimal number anywhere. And you cannot cross cancel. You deal with it. Okay, well, I'll let you do this because you can do it. Let me see. Same idea here for 18. Is that okay? Like that? Is that okay?
Mm-hmm.
But 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 the 3/4 times this will be kind of nice for cross canceling. But let's have a look. 2/3 p, lowercase p. Hey, if you notice the variable is italic like this, it's lowercase, not capitalized. Make sure it's lowercase. Get be more kind of precise about what you write, because capital V, capital lowercase v. I was saying that in algebra, I guess it's like volume and then velocity. It could get confused. Yeah, make sure it's lowercase. All right, this one right here, I want to see 3/4 times 5/12. Yeah, you can cross cancel right here 4 times, and then you can continue on with that. Let me see. Double check. Yeah. Okay, let's see. I think you're good. Add both sides, 20, add both sides by 1/6, and then deal with it. Convert it in proper fraction if you need to. Is that okay?
Mm.
Okay. And let me look down further. Order operation, how comfortable are you now doing
Oh yeah.
these? All right? Yeah, I'll do a
Yeah.
bunch of things simultaneously, okay? Like a 9 and a 4 here, like that. And right here, 2, 6 minus 4 here, replacing them. But I think you get it. And then you don't multiply 3 yet, finish it off inside the bracket first. I think you're good here. 2 here, 4 here, right? Right?
Mm-hmm.
Let me see. All right, let's move on down here. We haven't done scientific notation for 2 weeks. What? Maybe you did it yesterday, maybe. Okay, standard form, it's good. I think move this 5 places over. And
Yeah.
okay, for review, B. How do you write B? Quickly, I think you got this.
So um you would have to put the decimal in between the 1 and the 9. So
Mm-hmm.
it's after the last 0. So you move it 5 places to the left. So then it would be 1.9 times 10 to the 5th power.
Okay, you want to double check? Is it to the 5th power?
Or 4. 4. To the
4.
4th.
Yeah, 4th power. Yeah, that's it. All right, dude. I think you got it. Pretty good stuff, man. I mean, you're like pretty quick. Yeah.